Okay, you've seen the importance of wire colors and switch positions in tracing a current path on the wiring diagram. So now let's put this information to work and trace through a complete circuit.
We'd like you to trace the headlight circuit on a 1980 CB750K. It will illustrate what you'll need to know to trace any other circuit on the wiring diagram.
Before we begin, you'll need a copy of the CB750K wiring diagram, which was shipped with this program. And you'll need a colored pencil to trace the circuit. You may stop at this frame to get the diagram and pencil. Press the stop button now. All right, let's get started. This customer's bike has a headlight that doesn't work on either high or low beam.
Now, your first step is always to verify the problem. Make sure that the headlight really doesn't work on either the high or low beam. Next, check the obvious. A quick visual inspection of the battery and cables. Then check the headlight fuse. If everything looks okay, you'll want to check for available voltage to the headlight. But notice, there are 3 wires at the headlight connector. The wiring diagram shows you that the blue wire feeds current for the high beam, and the white wire feeds current for the low beam, and the green wire is ground. So now you can check for voltage. With the ignition key on and the dimmer switch at the low beam position, you'd check the white wire for voltage. And with the dimmer switch at high, you'd check the blue wire. If voltage is available at the headlight connector, the wiring is okay. Chances are you have a headlight that needs replacing, but maybe not. You could have a bad connection at the bulb. Inspect the connector and terminals for corrosion, dirt, and looseness. Or you could have an open in the ground circuit. There could be voltage available at the bulb, but if the headlight isn't grounded correctly, it won't work. An easy check of the ground circuit is to connect the jumper lead from the headlight green terminal to a good chassis ground. If the headlight works, there's a fault in the ground circuit. If it doesn't, the headlight must be bad. Then you'd replace it. Okay, let's assume there's no voltage at the bulb. You're going to have to use your 12-volt test light to check the fuse. Check both sides of the fuse so you're sure it's good. The fuse may look good, but still be bad. Corrosion could be preventing good electrical contact, or the fuse could have a hairline crack you can't see. If there's voltage on both sides of the fuse, then you'll trace the circuit from the headlight back to the fuse until you locate the open.
First, trace the blue and white wires from the headlight to the dimmer switch. If necessary, you may stop the program to follow along on your wiring diagram. Press the stop button now. Okay, here we've highlighted the blue and white wires for you. This is the path they follow to the dimmer switch. Now notice that the blue wire is connected to another blue wire that goes to the high beam indicator bulb. That indicator bulb is on a parallel circuit, fed from this common point. If the high beam indicator works, you know that voltage is available in the high beam circuit, at least up to this common point. If the indicator doesn't work, the problem would have to be further back in the circuit. All right, let's move on to the dimmer switch.
Looking at the dimmer switch continuity table, you can see how the switch operates. On low beam, you should have voltage at the low terminal, and on high beam, you should have voltage at the high terminal. But let me ask you, which terminal should you check first? You may stop the program to think over your answer. Press the stop button now. The first terminal you should check is the HL terminal, the hot lead to the switch. You can't expect to get voltage through the switch if you don't have voltage to it. If you have voltage at the HL terminal, you'd then check power at the low and high terminals. If they're okay, the switch is okay. And you know that there's an open in the wiring somewhere between the dimmer switch and the headlight. But if you have voltage at the HL terminal and no voltage at either the low or high terminals, then you've got a bad switch. The switch is causing a permanent open in the circuit to the headlight.
Notice what's happened here. You've eliminated portions of the circuit, narrowing down the problem to isolate the cause. Notice that you've checked the component first and are slowly working back toward the voltage source.
Let's continue troubleshooting at the headlight dimmer switch. If there is no voltage at the HL terminal of the dimmer switch, you'll have to keep looking for the open. So from the dimmer switch HL terminal, trace the circuit to the starter switch.
If necessary, you may stop the program to follow along on your wiring diagram. Press the stop button now. Okay, you should have traced the blue wire with white tracer from the HL terminal of the dimmer switch up through two connectors and down to the HL terminal of the starter switch. Next, you would check for voltage at the starter switch. The continuity table shows that BAT5 carries battery voltage to HL whenever the starter switch is free or not pushed. As before, you'd first check for voltage coming to the switch, the BAT5 terminal. Then put your test light on the HL terminal and check for power coming through the switch. Of course, make sure that the starter switch is in the free position. If you get voltage at both terminals, the switch is okay. You've isolated the open to somewhere between the starter switch and the dimmer switch.
Your prime suspects here would be those two intermediate connectors between the starter switch and the dimmer switch. There's an open somewhere along the blue wire with white tracer, and corrosion, dirt, or a poor connection at the connectors is more likely than a broken wire.
If voltage is present at the starter switch BAT5 terminal, but not at the HL terminal, then you've obviously got a bad starter switch. Current cannot pass through it. But if no voltage is present at the BAT5 terminal, the problem is further back in the circuit, and you'll trace the black wire with red tracer back toward the battery until you find voltage. So continue tracing on the wiring diagram. If necessary, you may stop the program to follow along on your wiring diagram. Press the stop button now. All right, here you should have followed the black wire with red tracer from the starter switch through the large connector, then the smaller connector, and on to the headlight fuse. You know from the earlier check that voltage is available through the headlight fuse. So you have a problem in the wiring between the fuse and the starter switch.
Again, you're eliminating circuitry and isolating the cause. Check those connectors first, then the wire.
If there was no voltage at the fuse, you trace the circuit from the fuse to the ignition switch. Go ahead now and trace this portion of the circuit. If necessary, you may stop the program to follow along on your wiring diagram. Press the stop button now. Well, the black wire led out of the fuse box, down through a connector, and over to the IG terminal of the ignition switch.
If this black wire didn't have voltage at the headlight fuse, you'd most likely have a bunch of other electrical problems. Notice that the black wire supplies power to all four fuses. So all four of those circuits would be out unless there was an open inside the fuse box that just affected the headlight fuse. Plus, that same black wire from the ignition switch supplies voltage to the handlebar switch, the starter switch, and the voltage regulator. The customer would certainly have complained about more than just a headlight not working.
That's right. And if he were, you'd be checking the ignition switch. You'd look for 12 volts at the IG and BAT1 terminals, with the ignition switch on, naturally. If there's voltage at both terminals, the switch is okay, and you'd look for an open in the black wire to the fuses. If there's voltage at BAT1, but not at IG, then you've got a bad ignition switch, and it should be replaced. And if there's no voltage at either terminal, the problem would have to be somewhere between the ignition switch and the battery ground cable. Trace this last part of the circuit. If necessary, you may stop the program to follow along on your wiring diagram. Press the stop button now. should have traced the red wire from the ignition switch BAT1 terminal down and across to the starter relay switch, through the main fuse, and on to the battery and ground connection. Well, that's it. You've seen how to trace step by step through the entire headlight circuit from component to power source. On the back of your CB750K wiring diagram, the headlight circuit is highlighted.
Remember to eliminate portions of the circuit to isolate the cause of the problem. That's really important when using a wiring diagram to troubleshoot an electrical problem. A little practice using the wiring diagrams will go a long way toward making you a better and more confident professional.
And thanks for watching.